Hey guys, welcome back. Today, I want to talk about 12 things you should know about spring. Now, if you're currently looking for work and you decide to put spring or spring framework as experience on your resume, there are a couple of things that you need to know about the spring framework. Now, in this video, I'm going to go over some of the basic things that every developer should know when they're working with the spring framework. And this is what we're going to go over today. Things you should know about spring. Now, these questions are questions that I've constructed over a series of interviews, and more than likely, if you put spring framework on your resume, you are going to be asked some questions like this, or questions that resemble these questions that I have here. Alright, so first, what is the spring framework? Number two, what are the advantages of spring? Number three, what's the differences between spring versus spring boot? What is auto wiring? What is an IOC container? And then name them. What are the types of auto wiring modes? What are bean scopes? Name them. What is the difference between singleton and prototype scope? What is a bean? How do you use the annotations component, auto wire, rest controller, and request mapping? What are the different modules in Spring? What is Spring MVC? So, let's start this thing off. Number one, what is the Spring Framework? The Spring Framework is an application development framework for enterprise applications in Java. There are extensions in the Spring Framework that are used for building web applications on top of Java EE platform. The goal of Spring is to make J2EE development easier to use and promote good programming practice. Alright, number two. What are the advantages of the Spring Framework? Now, when it comes to the Spring Framework, there are many advantages of the Spring Framework, but right now I'm just going to narrow this down to four. The first advantage is that Spring is lightweight. Is lightweight. So what I mean by lightweight is that it's a framework that does not need to be completely loaded to be useful. So Spring Framework is very large, so there may be a point in which you're only working with one component of the Spring Framework and you don't need to work with any of the other components, which makes it lightweight. So you don't have to use you can only use one. You have the ability to use one framework without using another one, to pretty much sum that up. Another thing about Spring is that it's flexible. You have the ability to use dependency injection. Another thing is that it can be configured in XML or in an annotation-based style. So by flexible, I pretty much mean that you have the ability to choose whatever type of configuration style you want to configure your application. Maybe you're more comfortable with XML, maybe you're more comfortable with an annotation-based style implementation. Another thing is that Spring is loosely coupled. So when it comes to Spring, it is a framework that is primarily based on dependency injection, which is basically the process of decoupling classes from what they depend on. It allows classes to be more independent and allows you to test your classes independently. Another thing, it's easy to test. Spring provides testing modules that make testing a whole lot easier. Alright, number three. What's the difference between Spring and Spring Boot? Now, I've actually went over the key differences between Spring and Spring Boot in a previous video, but right now I'm just going to explain, some of the key differences between the two. So Spring, when you're working with Spring and building applications in Spring, it's an XML-based configuration. Now, with that being said, it takes a lot more work to create and execute applications that you create in Spring. And it also consists of more boilerplate code, which basically means you write a lot of code in order to do very minimal tasks. Now, Spring Boot is an annotation-based style. Now, with the annotation-based style, it allows you to develop applications a whole lot more quicker. It also reduces the amount of boilerplate code in your application. Number four, what is auto wiring? Auto wiring is the process of injecting object dependencies. Objects can be injected in setter or constructors of a class. So this is XML auto wiring, and I'm going to show you how to actually go about doing that. Alright, so what we want to first start off with is this ball.java class that we have at the bottom here. Alright, so this ball.java class, it consists of 3 data members here: color, owner, and type. And somewhere in this class we also have the associated getter and setter methods of this ball class here. And we also have this method down here called toString, which is simply just going to return a string with the associated data member that is passed in. Alright, so this right here is how we're going to actually do our auto wiring in XML. So in our beans.xml file, we have this element that is called bean, and in this bean we're going to pass in 2 attributes to this element, which is the ID as well as the class. So the ID is going to be set equal to ball, and this ID simply just identifies this particular bean in this beans.xml file. Then we have the class, which is going to be set equal to the fully qualified name of the class that we're creating a bean for. And since we have the ball class down here, we're just creating the bean for that particular class. Now, if we want to go about injecting dependencies within this ball class, we would then go inside of our bean element and add another element called property. And in this property element, we will pass in 2 attributes: the name as well as the value. The name is going to be associated with the name of the attribute that we have in our ball class, and then we have a value, which is the data that we want to inject into that setter method in the ball class down here. And I'm doing the same thing for the other attributes that I've declared in this ball class down here as well. Now, the last thing that we're going to do is actually go up to our app.java class, which is our application object, and it consists of a main method. In this main method, we've created an IOC container, which is basically used to manage the beans that we create in this beans.xml file. And then we are creating a new instance of this ball. So instead of going ball b equals new ball, we're creating an instance of the ball based on, so it's basically going to be a class that's managed by the IOC container. So this is the way that we would go about creating a new instance of ball. We would simply just go context.getBean, and then up here we just cast it as a ball, and then from there we'll have a new object of the ball, and then simply the last line we're just simply printing out the string b.toString. And once we run this application, we should get this red football belongs to Max. So as you can see here, each one of these getter methods is going to correspond with the value passed into each one of these data members that we have in our ball class here. So that's XML auto wiring. Now there's another type of auto wiring that you can incorporate within your application called annotation auto wiring. Now when it comes to annotation auto wiring, it's done in a slightly different way, but it does cut down on a lot of the XML configuration that you would have to do in your beans.xml file. Alright, so we want to start off with this remote.java class that we have down here. So in this remote.java class, we have a setter method for this TV that we have down here. We have our setter method, and basically what we're doing up here is just creating a data member of TV, and we're passing it into this setter method right here. I think the closing bracket down here is kind of cut off, but this is the set TV method that we have down here. Now what's happening now is that we're using this annotation called AutoWire, which is going to inject the dependency into this setter method right here. And we also have another method down here called perform action, which is just going to call the TV class and is going to pretty much just have a system.out.console method in here that prints out power is on. And then down here we have another method that we call check channel change, and it's just going to say channel has been changed. All right, so we're injecting dependency using this auto wire right here. But in order to use these annotations, we have to go to our bean.xml and add context annotation config, which is going to allow us to use annotations and inject dependency with those annotations. And we also are going to need this component scan in order to scan all of the classes within our application, so that they can be recognized as beans, pretty much. Okay, now we go up to this application object. Just like before, we have this main method. We're creating a new, we creating an IOC container application context, and we're passing in the beans.xml. From there, we're creating a new instance here, but the thing about it, we're passing in the actual class name, remote.class, instead of the ID that was once here before in our XML auto wiring. And from there, we'll get whatever value shows up after these methods are executed. So that's how you would use annotation auto wiring. All right, number 5. What is an IOC container? An IOC container is basically a framework that is used to create and inject dependencies automatically. Now, when it comes to working with IOC containers, there are 2 types of containers. We have a bean factory and we have an application context. Now, with the bean factory here, it has since then been depreciated, and a lot of people nowadays are using this advanced container, this application context. But just explain this bean factory, it's a simple container that is used for dependency injection, and application context is an advanced container used for dependency injection. So with the bean factory, this is how you would go about setting it up. You're just passing your beans.xml file here, and you'll create an object of XML bean factory. But a lot of people nowadays are using this application context factory. As I said before, this bean factory has since then been depreciated, and just wanted to give you an idea of what these 2 IOC containers look like. Number 6. What are the types of auto wiring modes? Now, when it comes to auto wiring modes, there are 3 auto wiring modes: by name, by type, and constructor. Now, by name is basically an auto wiring mode in which you would inject the dependency based on the property name. The by type is going to be when you inject a dependency based on the data type, and then constructor is when you inject the dependency to that constructor, to a constructor of a class. Number 7. What are bean scopes? Bean scopes are used to determine the type of bean instance that should be returned. Alright, so when it comes to the different scopes, there are 5 different scopes. Alright, we have the singleton, prototype, request, session, and global session. Okay, the ones that are most popularly used are the singleton and prototype scopes, though. But I'm just going to run through, quick definition of each one of these scopes, and hopefully you grasp an understanding of what each one of these scopes mean. Alright, so we have the singleton, which is going to return a single bean instance per Spring IOC container. Then we have a prototype, which is used to return a new bean instance each time when it's requested. Next, the request scope is used to return a single bean instance per HTTP request. The session is basically used to return a single bean instance per HTTP session, whereas the global session is used to return a single bean instance per global HTTP session. Alright, so these are the different types of scopes. If you're ever asked to list out all the scopes in Spring, you know exactly what they are: the singleton, prototype, request, session, and global session. Question number 8. What's the difference between singleton and prototype scopes? Okay, so the first thing we're going to talk about is singleton. Now, as I said before, singleton scope is basically a scope that returns a single bean instance per Spring IOC container. Alright, so in order to implement this singleton scope, we will have to go to our beans.xml file and then Just like before, we'll have our ID, our class, and then a fully qualified name of the class. And then we want to add another attribute that is called scope and set that equal to singleton. Now, when we're setting this equal to singleton right here, that means that we're going to do this. Return a single bean instance per Spring IOC container. So what that means is that if, first of all, if we go down, so what that means is this. We're going to go down to this app.java now, and we're doing exactly the same thing, creating our bean.xml in this container, this application context. We're creating a new instance of dog, and then we're setting bark right here to woof woof, right? And what we're doing after that is just simply printing out d.getBark, so we should get woof woof. That's what we get for that first line. And then what we're doing down here is just retrieving it again. So when we go about retrieving this again, it's going to return a single bean instance. So since this is already set to woof woof, and we call it again, we're going to get woof woof another time, since we're using the singleton scope here. Now, if we're using the prototype scope, as I said before, prototype is used to return a new bean instance each time when it's requested. So we're doing the same thing here. We're setting bark woof woof, but right here in this bean.xml, we're passing in the scope prototype. Now, as I said before, the prototype is used to return a new bean instance each time when it's requested. So we're requesting it right here. This is the first time that it's requested, and d.getBark, and this is already set to woof woof. Now we're trying to retrieve it again. When we try to retrieve it again, we're getting null. Now the reason we're getting null is because whenever we call it, it's going to retrieve a new instance. So this instance is already set, d.setBark, but we haven't set d2 down here .set bark to anything. And that's what prototype is really all about. If we don't set that bark in this particular object down here, then we're gonna get null, because simply nothing has been passed in here. So you can really see the difference between singleton and prototype. Number 9, what is a bean? A bean is just basically an object that is managed by an IOC container. If you're asked this on an interview, that's a pretty simple definition. It's an object managed by Spring IOC container. Number 10, how do you use the annotations at component, AutoWire, REST controller, and request mapping? Okay, so these are the annotations that I'm going to be talking about today, the at component annotation. Now, this is an annotation that's used to mark a class that will be registered in context as a bean. So you can go about and mark this class as a bean if you want to label it as a bean, instead of actually going into your XML configuration file. It's automatically going to be marked. So annotations, as I said before, they cut down a lot of the code that you would have to write in XML. It reduces a lot of that boilerplate type code that you would have to write. Another thing is auto wiring. Auto wiring is basically when you auto wire, or you inject dependencies into your class. You would just annotate the setter method that you're using and saying, you would just annotate the setter method, and then from there it's just saying, hey, this class is something's going to be injected into this particular method, or in this particular setter method. All right, now the controller annotation is basically used to mark a class as controller in Spring MVC. So if you worked with Model View Controller before, you know that it's basically a design pattern that's used to incorporate a separation of concerns within your web application. And Spring MVC just allows you to add an annotation to that controller class to identify it as a controller class, pretty much. Now, the REST controller is basically used to mark a class as controller when developing RESTful web services. Next is request mapping. If you're working with web services, again, the request mapping is It's basically used to map URLs to a class or a handler method when developing REST web service applications. All right. Number 11. What are the different modules in Spring? Now, these are all the different modules in Spring, as you can see here. Spring Framework Runtime. So all these are modules in Spring. We have the data access, we have the web module, we have the AOP. This is all a part of the same module, AOP aspects and instrumentation. These are all one module. We also have the Spring Core module as well as the testing module. So remember, there are 5 modules here. 1, 2, 3, 4, 5. All these are modules in Spring. Now I'm just gonna go through really briefly what each one of these modules contain and what they actually do. So the Spring Core is the basic module that Spring provides. It provides a lot of the fundamental parts of Spring, as far as ILC container as well as dependency injection type features. The next thing is the data access module. Now this is associated with a lot of the persistence layer, of the application, a lot of JDBC, ORM, OXM, JMS, and transaction modules. Web is basically pretty self-explanatory. It's if you're dealing with any type of web-based applications, working with servlets, and it's basically just a module related to web application development. Then we have the AOP aspect instrumentation module. For me, I haven't really worked with this module before, but what it actually does, it is associated with a lot of aspect-oriented type programming. And then last thing is going to be the testing module, and it's basically used to support unit test integration using JUnit, things like testng, as well as mock objects, which are basically things that are used, for testing code individually, pretty much. Finally, question number 12. What is Spring MVC? Spring MVC is basically just a component of the Spring framework that is used to implement the MVC design pattern. So just like MVC design pattern itself, Spring provides a design pattern that is that allows you to go in and create your own web-based applications. Now, this is something that you need to know. I remember I was asked on an interview about Spring MVC to actually draw out the chart, but I wasn't too familiar with Spring MVC, so I had to go home, do some research, and this is a chart right here. And I'm kind of going to show you. I'm going to show you how this works. So, okay, let's say the client is sending a request. The client sends a request to this thing called the dispatch servlet, and it's going to make its way through each one of these steps. So it's send a request to the dispatch servlet. Dispatch servlet has this thing called a handler mapper. So whatever URL that the user is trying to access is going to make its way here, and then from here is going to make its way back to the dispatch servlet. The dispatch servlet is then going to redirect that to the controller class, and then from there it can either call the more than likely the get or the post method that is used to handle that particular request, and just make it. Then after it's done doing that and processing whatever information it needs to process, it makes its way back to the dispatcher servlet, and then from there it makes its way to the view resolver, which is used to create the view. Pretty much it prepares the view before it actually goes out, makes its way back to the dispatch servlet, and then finally is going to give the finalization of the view that has been constructed, and then send back information to the dispatch servlet. And then once everything is prepared and all the data has been collected and is ready, and the response is ready, is going to send the response back to the client. That's pretty much how the Spring MVC Spring MVC works. Now, if you have any questions, leave them in the comments below. Don't forget to like the video if you've learned something here. Also, don't forget to subscribe, and see you in the next one.